Technologies continue to improve, and the accuracy of the estimate improves along with it.
It is proven impossible to find any natural source of carbon that does not contain significant amounts of C14. Radiation from the sun strikes the atmosphere and produces radioactive carbon-14. This combines with oxygen to make radioactive carbon dioxide. So the plants are breathing this stuff in all the time, so they make it part of the plant. Animals come along and eat the plant, so now it becomes part of the animal. So the assumption is when the plant dies or the animal dies, it stops taking in more C14. And therefore we can tell how long it's been dead based upon comparing the amount in the fossil to the amount in the atmosphere today. Willard Libby made up this carbon dating stuff, 1955, well, before that, but they collide with atmospheric nitrogen, produce carbon-14. So there's a big article in Time magazine from 60, 70 years ago. Cosmic radiation converts 21 pounds of nitrogen to carbon-14 every year. Carbon and nitrogen are right next to each other on the periodic table. So it slams into the nitrogen, knocks a few things off, and makes it carbon-14, radioactive carbon. A Geiger counter can be used to test how much carbon, radioactive material, like carbon or uranium or something like that. Carbon-14 is being produced in the atmosphere by the sun. It breaks down to nitrogen at the rate of half of it every 5,730 years. Okay? During photosynthesis, plants breathe in CO2 and make it part of their tissue. So that's the photosynthesis formula there. Animals eat the plants and make it part of their body. So to carbon date something, you are assuming you know how much was in it when it started. It's assumed the ratio of carbon-14 to carbon-12 in the atmosphere would be the same found in plants and animals that are alive today. The atmosphere today is 0.0000765%, so they assume the plants and animals started with the same number. There's no way to know that. When the plant or animal dies, it stops taking in any more C14. I would agree with that. So they compare the amount in the object being dated with the amount currently in the atmosphere, and they estimate how long it's been dead. If it has only half as much, it's been dead 5,730 years, one half-life. Whatever it had continues to decay. Half of it is gone in 5,700 years. It can't get any more, so it's going out of balance with the atmosphere. That's 0 years old, 5,700 years old, 11,000, 17,000, etc. They're dealing with a real tiny amount here, but I won't argue that. They can measure it, okay? So it goes from a half to a fourth to an eighth to a 16th. There should be no measurable carbon-14 after 40 to 50,000 years. So if somebody tells you we can measure this thing as millions of years old because of carbon dating, you can mark them down. They don't have a clue what they're talking about, okay?